Hello guys, this is Christine again, and this is part 2 of how to predict the product of SN1, SN2, E1 and E2 reaction. So if you have not checked out their first video of mine about the summary table of how to predict these products, please check it out on that video. I have better explaining that, and here's a table that I made. You can take a quick look at that to kind of like remember what I said in the video. So let's go on to some example to get to understand it better. So now, for example, let's predict the major product of these reaction. For example, if I have this. So the first thing, whenever you want to predict a major product of a reaction, you want to know what do you have, a base or a nucleophile, and what is your substrate, what is your alkyl halide. So in this case, at first, if I look at my base, NaOH is really NaOH is a really strong base, and it is a really strong nucleophile. And sorry for the first video, I made a mistake. There's no NaOH here. I'm sorry about that. It should be water, CH3OH, or it can be CH3, CH2OH, but there's no NaOH. I made a mistake in there. So if I look at this, I have NaOH. This is a really strong base and really strong nucleophile. It's actually OH only, because we don't consider Na+. These are an ionic compound. So when it is dissolved in water, it makes Na+ and OH-. This OH- represents the OH in here, which is a strong base and strong nucleophile. So now if I know, it can be either through SN2, E2 reaction. However, if I look at my substrate, I have a primary substrate, a primary alkyl halide. If I have a primary alkyl halide with strong base, strong nucleophile, it will do SN2 as a major product and E2 as a minor product. So in here, the product present should be an SN2 product, and this reaction should occur as an SN2 reaction. And this product should be like this. After the substitution, we will have this. So we have an alcohol of the substitution reaction of SN2. Alright, let's move on to this example. So we have CH3ONA and this substrate. First, you want to see if you have a what do you have? You have a base or you have a nucleophile, is it strong or weak? So CH3ONA, this is an ionic compound. So when it dissolves C8 in aqueous solution, we have CH3O with the lone pair and Na+. So as I said earlier in the first video, if you have a lone pair right next to an oxygen, this is a really strong base and strong nucleophile. And also if we see that we have a tertiary alkyl halide. So we have a tertiary alkyl halide, a strong base and a strong nucleophile. They will proceed at E2 reaction. There's no SN2 reaction because SN2 reaction only favor in primary and secondary reaction. Primary and secondary alkyl halide. SN2 reaction is never favored in tertiary reaction. That's why we only have E2 reaction in here. So if we have an elimination reaction, and when you have elimination reaction, you always of an E2 elimination reaction E2, you always want to see if you have a small base or you have a Berkey base. If you have a small base, it will do Zysep product. If you have a Berkey base, it would do Hoffman product. In this case, I have this as a minor, is a small base. So because this is a small base, you're going to do E2 reaction. I will have Zysep product. So now I will have a Zysep product. However, in this case, we don't have Zysep or Hoffman. So in any case, it will give you only one product. But in case if you can have possible, you can have Hoffman or Zaitsev with a small base, it will favor Zaitsev product. And from here, I want to point out also that small base is some base like OH, this, or CO3. So any you can see it little. It have only a little bit of it have like 4 or 5 atoms. Is small, but this is a Berkey base. So why it is a Berkey base? It's had a branch. It's had branches. It's really Berkey. We have branches. So if it have branches, you're going to do Hoffman products. And also we also have DBN and DBU. They are really Berkey based also that would favor Hoffman products. Okay. So let's move on to the next example. So this we have E2 reaction, and this is our product. Let's move on to the next example. So now let's see what do we have? CaOH. So this is not an ionic compound. Don't confuse it with CaO and A or CaO here. Don't confuse this with this. This is not an ionic compound. It never dissociates in water, so it's not gonna separate or split. So it keeps like this. So this is a weak base and a weak nucleophile. And we have Ca3OH. And also, we have our substrates is a tertiary substrates. So we have tertiary substrates. It can either do SN1 or E1 products. However, if in this case, we don't say anything, we have Mr. product. So we have 2 reaction will occur, SN1 and E1 reaction. So if we have SN1 reaction, our product will be like this. OCF3 for the SN1 product. And for the E1 product, we have this. And also, you guys want to remember that E1 products always have only favor Zaitsev. Never has Hoffman, because this is a really slow process. The reaction occurs really slow rate. So it's always favor Zaitsev product. Okay, so this is, we have a Mr. product, SN1 and E1. This, you don't have any clue to say if it's major or minor. Alright, so let's move on to the next example. Here we have water. Water is a weak base and a weak nucleophile. And we have a tertiary alkyl halide. Would this indicate that we favor SN1 or E1 product? And also that we have, you want to see this is heat. And remember that in the table we also take a note that heat will favor E1 reaction. So in this case, we will have E1 product as a major product. So now my major product will be this elimination reaction. And I have SN1 may occur, but it's a minor product. So this is my product. All right. For the next example, so let's take a look at here. We have DBN. DBN is a really strong base and is a really strong nucleophile. I'm sorry, it is a really strong base, but it is a weak nucleophile. So whenever you have a strong base and weak nucleophile, it's always do E2 reaction. So it's always do E2 reaction. In this case, you want to consider whenever you have E2, you want to see if your base big or small. DBN is one of the big base. It's a Berkey base. So whenever you have DBN or DBU, you do Hoffman product. So in this case, my major product will be Hoffman product. So if you see that, if you point out, you can look at here and you can see either their double bond can either form here or can either form here, right around their bromide, just around the bromide at this point, right? You can either form here or you can do either form here. But if it's formed here, this is their Hoffman product. If it's formed here, this is a Zaitsev product. So it will favor Hoffman product, which is right here. Okay. All right, let us move on to the next one. If we have this product, and we have NaH. NaH is a really strong base, a weak nucleophile. And also we have NaH is also a really small base, so it will favor Zycep products. If it's favor Zycep product, this is an E2 reaction because this is a strong base, weak nucleophile. Also is a small base, so it will favor Zycep product. So this is our product, the major product. And also we have for the next example, we have ETO. So as I said earlier, remember that whenever you have a lone pair right next to an oxygen, this is a really strong base and strong nucleophile. So it can do either SN2 or E2. But if you look at the substrate, this is tertiary. Tertiary alkyl halide never favor SN2 reaction. So this is only occur as an E2 product only. And when you have an E2 reaction, you want to consider if you have a small base or a bulky base. In this case, you have a small base. So this will favor Zycep product. So if you have a Zycep product, this is what you get. But however, in this case, we don't distinguish between Zycep and Hoffman. So we only have one product here. All right, let's move to the next one. So in this case, we have NABR. NABR, we have bromide is a strong nucleophile and a weak base. So it can do either SN2 or SN1. However, if we look at the substrate, we have a primary substrate, a primary alkyl halide. So this only favor SN2 reaction. So remember that primary alkyl halide always favor SN2 reaction, never favor SN1 reaction. So in this case, we have an SN2 reaction, and this is our product. All right. And in this problem, so we have water is a weak base and weak nucleophile. So it can do either SN1 or E1. But in here, you see that your substrate is actually primary. So you may wonder, is primary, did you just said that primary alkyl halide never favor SN1? Yes, I did say that. However, this is in the allylic position, is mean that have resonance. Only in the case that they have resonance, it also can do SN1 reaction. Even though it's primary, but is an alkyl, is in allylic position. So this one can also do SN1 reaction and is even really reactive because resonance is a major factor to stabilize the carbocation of SN1 reaction. So this can do either, it can also do SN1 reaction. And we also have the in here, water is a weak base and weak nucleophile. So it cannot do SN2 reaction. It cannot do SN2 reaction. And in here, we see that this can do SN1 reaction. And this also favor SN1 reaction. So this will occur as SN1 reaction. We don't do elimination reaction because if you do elimination reaction, you're going to have double bond here and double bond in here. That doesn't look right. So in here, for the allylic, you will have the SN1 reaction, and this is your major product. All right. And next for this, we have C3SH. So as I said earlier, this too has a lone pair in here. So this lone pair on sulfide is a really strong nucleophile and is a weak base. So it can do either SN1 or SN2 reaction. However, our substrate is a tertiary alkyl halide. Tertiary alkyl halide always favor as SN1 reaction and never favor SN2 reaction. So in here we have an SN1 reaction. So in this case, this is our major products. And you're gonna want to be careful with this too, because a lot of time student would put this instead of the product. They will put this SH. So this is not correct. This is not right. It's going with SC3, and it take the H away. It don't go with HH. All right. So these are some examples, and good luck with all you guys for studying chemistry, organic chemistry. I hope that this video is helpful and help you guys understand a little bit better about organic chemistry. Yeah, so thank you for watching the video. Bye.